In this video, we're going to look at this problem on page 12 of the 9.1 slides. To keep track of the location of its cabs, Zephyr Cab has divided a town into 3 zones, Zone 1, Zone 2, and Zone 3. Of the passengers picked up in Zone 1, 60% are discharged in the same zone, 30% are discharged in Zone 2, and 10% are discharged in Zone 3. Of those picked up in Zone 2, 40% are discharged in Zone 1, 30% are discharged in Zone 2, and 30% are discharged in Zone 3. And of those picked up in Zone 3, 30% are discharged in Zone 1, 30% are discharged in Zone 2, and 40% are discharged in Zone 3. At the beginning of the day, 80% of the cabs are in Zone 1, 15% are in Zone 2, and 5% are in Zone 3. Furthermore, a taxi without a passenger will cruise within the zone it is currently in until a pickup is made. So the first question asks us to find the transition matrix for the Markov chain that describes the successive locations of a cab. So we're going to base this entirely on the details we're given, and there are a lot of them in that block of text there. So let's come over here and we'll look at that. So we're told that for Zone 1, Zone 2, these are the origins. Yeah, and on the columns are going to be origins, and the rows are destinations. And we're told that 60% of the passengers picked up in Zone 1 are discharged in Zone 1, so that's 0.6. 30% are discharged in Zone 2, and 10% are discharged in Zone 3. 40% are discharged of the passengers picked up in Zone 2 are discharged in Zone 1. 30% in Zone 2 and 30% in Zone 3. And of those picked up in Zone 3, 30% are discharged in Zone 1, 30% in Zone 2, and 40% in Zone 3. So this very quickly becomes our transition matrix. T equals 0.6, 0.3, 0.1, 0.4, 0.3, 0.3, 0.3, 0.3, 0.4. Moving on to our next question, what is the distribution of the cabs after all of them have made one pickup and discharge? Well, to do this, we need to use that last bit of information we get. 80% of the cabs start in Zone 1, 15% in Zone 2, and 5% are in Zone 3, which gives us a distribution vector x0 equals 0.80, 0.15, 0.05. So using our matrix and our distribution vector, x1, the location of the cabs after everybody's made one pickup and drop off, will be t times x0. Okay, so that's 0.6, 0.3, 0.1, 0.4, 0.3, 0.3, 0.3, 0.3, 0.4 times 0.80, 0.15, 0.05, and matrix multiplication gives us that this is equal to 0.555, 0.300, 0.145. After the first pickup and drop off, we have this new distribution where 55.5% of the cabs are in zone 1, 30% are in zone 2, and 14.5% are in zone 3. Our last question asks us, what is the distribution of the cabs after all of them have made 2 pickups and discharges? And that's just taking x2 equals tx1, which is going to be 0.6, 0.3, 0.1, 0.4, 0.3, 0.3, 0.3, 0.3, 0.4 times our x1 matrix, our x1 vector, 0.555, 0.300, 0.145, which gives us 0.4965, 49.65% in zone 1, 0.300, 30% in zone 2, and 0.2035, 20.35% in zone 3. That is it for this video. If you have any questions, please get in touch.